Hey everyone, Mr. Boykin here, Unit 7, Lesson 6, and we're going to be looking at a very typical question right here. And we're going to be forming a linear equation, which is y equals mx plus b. Remember, b is where we're starting. That's the when x is equal to 0, which is the y-intercept. X is just a coordinate, y is just a coordinate, and m is our slope. So if we look at the question right here, it states that this girl, Lisa, purchased a new car for $20,000. So that's where it's starting out. So what would that be? That would be our B value right there, would be 20,000. Now, when we look at the formula they've given us, they said V, which is the value of the car, equals 20,000, what you started off paying, and subtract $1,250 for every T, which is year. Now I can rewrite that in the y equals mx plus b format. Y is now equal to V, equals m is negative 1250, x is now represented by t, and the b is going to be 20,000. So essentially we're starting up at this point, which is going to be 20,000. And we should be going downwards until we eventually get to 0 right here. Okay, so what we need to do is graph this out and make sure that our thinking is correct. So we're going to turn this on, and I'm going to type in negative 1250x plus 20,123, and we'll graph that, and we're not seeing anything. And that's because our window right here is set up to a negative 10, positive 10 in both the X and Y direction. So I need to go into the window, and the easiest one to set right now is going to be our Y max. We know it's going all the way up to 20,000. So I might as well go down to here, my Y max, and I'll just set that to a little bit above that, like 21,000, and graph that again. Okay, good. So you can see up here, there's our y-intercept, and it's going down, and somewhere over here it's going to cross the x. So we need to go to the right more in the x direction. So if I go back to the window, that's going to be my x max. So right now it's at 10. Let's just go 20 and graph that again. And there, that looks pretty good. Now, if I want to use some of the other functions in here, such as these ones right here, my graph isn't set up that great. So I want to go a little bit lower on the y and probably a little bit higher on the y too. So if I go back into my window, if I go down to y minimum, it's at negative 10. So maybe I'll put negative 2,000, graph that again. So that gives us a little bit more room down here to do some work. And if I go back into the window on my Y max, instead of 21,000, maybe I'll put 25,000. And I could even go up here and change this one to a negative 5,000. Gives a little bit more space. That looks pretty good right there. Okay, so we already know our y-intercept value. Now we need to find our x-intercept value. Now again, you can do that by hand by replacing the y with 0 and just doing the math. And we can also go on to our calculator and use some of the functions. So what do I want to find? I want to find the 0. And if I come down here and it tells me to go a little bit to the left of the 0, which is going to be right there, then go a little bit to the right of the 0 and then hit enter. And you can see right here, x equals 16 when y is 0. So that means at year 16 is when the car value is going to be 0. So it should be 1, 2, 3, 4, 5, 6, 7, 8, 16. And basically that's going to be that point, and we're going to have a line going from here to here. Now in this case, it can't extend any more, can't extend any more in that direction or down in that direction because 20,000 is the cap. That's the most we've paid for it, and the lowest value it can ever be is 0. It can't be worth negative dollars. So there we go. This is going to be T, and that's going to be in years, and this is going to be the value, and it's going to be in dollars right here. Okay, let's move on to part B. It says calculate the t-intercept. Already did that using the graphing calculator and label it. Describe what this value represents. So that represents the number of years it's going to take for the value of the car to get to 0. Okay, part C. Calculate the v-intercept of the graph using a standard graphing calculator and label it on the sketch. Okay, well, we already did that just by looking at the equation, but again, remember in here we can just go trace 0, and that's going to give us our y-intercept right there. So at x, y is equal to 20,000, and that's as long as you've punched it into here correctly. Okay, so we've already done that one as well. What does that represent? Well, that represents the initial value of the car on the day that Lisa made the purchase. Use your trace feature of the graphing calculator to determine what will the car be worth in 5 years. So again, we want to know the x value because the years is down, that's the independent variable on the x. So I just go trace 5, enter, and it tells me that in 5 years the car will be worth $13,750. Okay, use the intersect function or feature of the graphing calculator to determine when the car will be worth half of the purchase. So that means it's going to be somewhere around here where it's going to be worth 10,000, and we're going to have this line that goes across, so that is the value we're looking for right there. That sort of intersection that happens at that point. So what we're going to want to do is go into our y equals, go down to a second graph, put in the value of y, which is just going to graph a straight line at that point, just like I have on the screen right there. And now what we need to do is to find that point. So I'm going to go into second trace, which is calculate. What am I trying to find? Number 5, which is an intersection, and it tells me to go a little bit left of the intersection and go down to the other line. So I'm on the other line, hit enter and enter, and here it says the car will be worth 10,000 when x, which is t, the number of years, equals 8. Okay, so this one happens to be 8 in this case. And write an appropriate domain and range. Okay, so remember what is domain and what is range. Okay, so if we need to find domain, remember that domain is the set of x values and range is the set of y values. So if we go back to our graph right here, and we're looking at the domain, which is x, where are we starting off? We're starting off right here, which is 0, and where are we going to? We're going to 16. So in this case, the domain is going to be, okay, so to write this out properly, we're going to be writing that the domain equals x, such that x is going to be greater than or equal to 0, and x is going to be less than or equal to 16, and x is a subset of all whole numbers. So it means that no, in fact it's going to be a subset of all real numbers in this case, because time is sort of infinite. We don't just have to stop at each year. So I could have 1.5 years, 1.55 years, 1.56839 years, etc. So in that case it's going to be a subset of all real numbers. And let's look at the y. The y is going all the way from 20,000 and then down to 0. Okay, so the range, I'll write it down here. The range is equal to y such that y is going to be greater than or equal to 0 and less than or equal to 20,000, and y is going to be a subset of all sort of it's not going to be whole numbers, it's not going to be natural numbers. I guess it's going to be all real numbers within that range. Okay, so there's that question, completely done. And let's move on to the next one. All right, so let's take a look at this new question, and right away I notice that there's a t squared in there. So this will not be a linear equation, this will be a quadratic equation, creating some type of parabola. So it says we've got h, which is usually height, good, and it's in meters, so it's important to go and grab all this stuff. So h is the height, it's in meters, so we're starting at 12 right there. That is our constant. So we're actually starting, somewhere up here, and that would be at 12 meters. So the cannon that they're shooting this thing from is above the ground. It says it's on top of some building, and it lands on a mat, is in a hole in the ground. Okay, and the mat is level with the ground. So somewhere down here, there's a mat down here, and basically they're going to shoot the ball. Cannonball, it's going to go up and reach a peak, and then it's going to come down and sort of end up right there, apparently. Now, you can see that this formula right here, we can rewrite that as h equals negative t squared plus 6t plus 12, and we can punch that in the calculator, but either way that you punch it in is going to be fine. I'd probably go with the original one, and only because just in case I made a mistake doing the conversion into that standard format right there. Okay, so this is going to be 12 plus 6t, which will be x, and minus x squared, and then we will graph it. And what the heck is that? Okay, it looks like we got a flat graph. That is not what we have sort of assumed would happen here, so it's probably something to do with my windows. And if I look back in here, this was set up for the last one with a y minimum of negative 5,000 and a max of positive 25,000. So that's just showing a range that's too huge, and we're not going to see that correct shape. So I need to come down here. Now the y minimum, it's not really going to go below zeros, but anyways, we'll start off. We'll maybe put something at, say, negative 10, just to show a little bit below there. And our y max, we're just going to have to sort of guess how high it's going. So it's starting off at 12 meters. I don't know, I'll try something like 50 meters. Our x minimum, again, I don't need to go all the way back to negative 10, but we'll leave it there for right now. And the y, or x max, well, we'll see what happens here. Boom. Okay, so that's not too bad. So I definitely didn't need to go as high in the y or as far over to the right in the x. So I can go back into here, and I can change this to, say, like 14, and come down here and change this to like 25 maybe. Graph that out. Looks a little bit better right there. Okay, now let's follow the rest of the questions and see what they're asking. So write down a window setting. I just gave you that, which was right here. There's no correct answer to this. It's just basically anything that is going to present the graph properly. Okay, now really it's never going to go back in time, so anything back on this side of the x in the negative is not really necessary. The only reason I put it like that is so that I can see my graph and where it's making these intersection points, and I can use some of these other functions. Okay, sketch it on the grid provided. Basically did that. What is the height of the cannon above the ground? What is the height of the cannon above the ground? Well, that's right here where it's starting out at 12. So it's going to be 12 meters. What is the maximum height that the cannon reaches? So that's going to be up here. So we've got to find that height right there. So that is a maximum. So we're going to go into our calculator and we're going to say second calc. Number 4 is maximum, and left bound, so I'm already left, hit enter, move over a little bit right of the peak there, or the apex, hit enter, then hit enter again, and it says that X is 2.999997 and Y is 21. So the maximum height that it met was 21 meters. How many seconds does it take the cano to reach the highest point? Okay, well that's going to be in the time right down here, and you can see that that is going to be basically 3 seconds. Okay, so that was 3 seconds. Just want to make sure that T, it should tell us T is time in seconds. So you always want to double check, make sure that that's correct. So T is time in seconds. To the nearest hundredth of a second, how long does it take the cano to land on the mat? Okay, well, that is going to be at that point right there. So again, that's at our 0 or our Y, our x-intercept that's right here. Okay, so if I go to second trace, which is calc, choose 2, which is 0, and again, I want to come down to here, so I'm a little bit left of that, enter, a little bit right of that, enter, hit enter again, and it tells me it hits the mat, which is Y0, at 7.582, and round to the nearest hundredth would be 7.58. And don't forget your units, so that's 7.58 seconds. And that's right there too. How high is the cano after 1 second? So there's 1, 2, 3, like that. So basically we're going up and we're trying to find that height right there. And again, this one's easy. I just have to go trace 1 for x equals 1, and it tells me y is 17, which is going to be 17 meters. When will cano be at the height h again? So I guess when will it reach this point right here? So that's basically at 12. Okay, so again, I can just go into my y equals, drop this down, make another graph at 12, and I want to find this intersection point right there. Okay, so again, I'm just going to go second trace. That is an intersection, which is 5. And I want to go a little bit to the left, enter, a little bit to, oh no, this one's not to the right. It's the same, choose the second curve, enter and enter. And right there it says at 6 seconds, the cannonball will be at 12 meters. So what is the height? Or time, when will it be there? At 6 seconds. In words, describe the relation connecting height and time. Okay, I just wrote that down so you didn't have to watch me write it all out for you, but this is basically explaining this graph right here. So it says the cano is shot from a starting height of 12 meters. It is projected in an upwards direction, and after 3 seconds at a height of 21 meters, it reaches its apex or its maximum height. It then starts to fall downwards and hits the mat, which is at 0 meters. after 7.58 seconds. Okay, and the last one basically says write an appropriate domain and range. Remember, domain is x and range is going to be y. So let's take a look at our x values to begin with. So x is going to be starting at 0 and ending at 7.58 seconds. So the domain is going to equal, now I could put x, but really what we should be writing there is, what is the x called? It's h. No, it's t. Okay, is t such that t is greater than or equal to 0 and less than or equal to 7.58. And t is a subset of all real numbers. Okay, and a little squiggly bracket at the end there. And the range, let's take a look at the range. Well, where is the range going to be starting out at? Well, it goes all the way down to 0 right here, and it goes all the way up to 21. So it's anywhere in between and including that as well. So the range is h such that h is greater than or equal to 0 and less than or equal to 21, and h is a subset of all real numbers. There we go. There's those two very typical questions. And now there's some assignments, questions number 1 to 6 to complete in the book.